Welcome back, Organic Chemistry. I am so excited. I usually am though, right? I am excited to introduce a problem type at the end of our Unit 1 that I like to call roadmaps. Now, I learned these as I was a young pup in organic chemistry, and they were super fun. Sometimes if you Google roadmap for organic chemistry, you're going to come up with something just a little bit different, and we will use that kind of roadmap when we start hitting reactions. Probably in Unit 3, we'll start to make something like a diagram or a reaction map of all the reactions that we're learning. But these are just fun puzzles. They are literally at the end of this unit for a reason. We will have a roadmap on every single test. What I'm doing in a roadmap is, number one, we're going to test to see how well you really can draw and think about all of the terms that we just used in this unit. So included in our roadmap is going to be things like our formula. I'm going to give you primary, secondary, tertiary. I'm going to give you symmetry. Now, all of these things, there is a thought process behind my madness. These things are in a roadmap, so you could start thinking about how you're going to apply the knowledge that we just learned, but also for two other reasons. All right, so number one, I just want to make sure you know those concepts. Number two, this is literally as if we're working in the lab. So one of the reasons I love roadmaps is that we're literally going to start with a formula and by the end be able to draw a structure. These are the ultimate puzzle. But in true honesty in organic chemistry, this is the process you would go through, very similar when you're actually doing reactions and doing lab work and trying to figure out what in the Sam heck you just made. Or if you've got a mysterious substance and you've got to figure out what it is. One of the first instruments that we'll learn, so this is leading us up into instrumental analysis. So I want to start to train our brains already picturing our OChem 2 spectroscopy. All right, all of our spectroscopy problems are all connected and they're all puzzles. So I want to start training your brain that way. Literally, one of the first instruments that we started using in organic chemistry, and actually all of chemistry, was our mass spec and elemental analysis. And guess what? We will start those in OChem 2, and guess what they give you? Formula. You've already started to think about these back in Gen Chem when you solve for your empirical formula. So we're going to start with a formula, but then we have to literally gain more information to be able to draw the structure. And I think by now in our unit, you can tell that for every formula, holy crap, can we have an awful lot of isomers, right? So could you imagine being in the lab and having somebody hand you a clear solution and they ask you, well, what is it? It's C4H8. Okay. Well, that could be several things, right? So we're going to use some other instruments. A perfect instrument that can give us information like primary, secondary, tertiary, we will learn in OChem 2 as NMR. So I'm going to start to train your brain. I'm going to give you this for free so we can start to slim down that pool of isomers. Let's slim it down. And then another piece of information we're going to get is symmetry. Symmetry we can also get from NMR in OChem 2. So all of these, again, there is a rhyme to my madness or a reason to my madness. I'm trying to train our brains for some later problems in organic chemistry. And we are going to add to this in each one of our units. One of the things we're going to add in Unit 2 is an instrument we're actually going to look like, IR, and it's going to tell us functional group. So now we're going to take our roadmaps and include all of our functional groups. For this first unit, let's look at what a sample roadmap would look like. And then we're going to look at maybe some ideas for how to solve it. So a sample roadmap, I might give you a sample and ask you to come up with a structure. And you do have an entire homework just on these roadmaps. And I'll always give you the formula. Okay, now starting in OChem 2, I'll take away the formula and I'll give you mass spec. So I'm just going to give a little OChem 2 hint. This is a skill we're going to learn for the whole year of organic chemistry. Okay, that's fine. So I just gave you a formula. And then I'm going to give you some ideas. All right, if I were in the lab and the first piece of information I got back was a mass spec and I could figure out that I had C8H16, awesome. And then I went ahead and submit for NMR. And I'm told that I've got 5 secondary carbons, 2 primary carbons, and 1 quaternary carbon. Okay, well that's actually starting to tell me quite a bit. Okay, now this kind of information, like I said, as we work our way into later OChem, NMR can provide that. And then finally, I'm going to ask you to give me a structure that has both C2 and a plane of symmetry. Okay, I love it. I love it. So this is one massive puzzle. Now I'm going to take you through the process I use, but you can honestly use whatever process works for you. I like to start right away with what we learned about our alkane formulas. So C8H16. Right away, I'm going to ask myself, is there a ring or not? Or do we have more than one ring? How can I tell? Right there. Okay. So this formula tells me that I have a ring. So I'm going to just start with that C8H16, and I'm going to give myself an idea of the ring sizes that we can have. Remember, we can't be smaller than a cyclopropane. And then we have a cyclobutane, cyclopentane, cyclohexane. We even have a cycloheptane and a cyclooctane. All right, so these are my possible ring sizes. I can't get larger than that because I run out of carbons. So then I start looking at my list of requirements. And the first thing I notice is that I have at least 2 primary carbons. Okay, what does that help me do? Right away, I'm going to eliminate my C8 because I have only secondary carbons, and my C7 because even though I get to add a carbon to this one, I still can only ever have 1 primary carbon. So I'm going to cross off both of those ring sizes. Okay. And then I typically word in my questions somewhere, I was able to heat and I was able to keep that structure. I usually put something with heat in there. If heat is mentioned, we cross off cyclobutane. Remember, cyclobutanes will blow up on a little bit of heat. So there you go. I'm down to 3 different ring sizes. Now is my favorite part of these puzzles. You just start to draw. Literally, fill a sheet, just start to draw. If I have a cyclopropane, that's 3 carbons. 1, 2, that's 5, 6, 7, 8. Okay, I just started drawing. What about something like this? There's 6, 7, 8. Okay. What about with a 5-membered ring? I've got 5, 6, 7, 8. How about 5, 6, 7, 8? There's just all kinds of isomers that we can draw. What about our cyclohexane? Then I've got 2 carbons. That looks an awful lot like our last video, doesn't it? Something like this or something like this. All right, so you get the idea. All right, you've got a lot of stuff hanging off the cyclopropanes. You've got 3 that have to be attached to your pentanes, and you've got 2 carbons on your cyclohexanes. So the beauty of a roadmap is sometimes there's not just one answer. That's why I love to just start drawing. Can we start crossing off any of them yet? Well, this is where the fun happens, right here. The fun starts to happen in these requirements. We have to have at least 5 secondary carbons. Okay, so in something like this, no. How about this one? Nope. How about over here? Nope. Here we do. In fact, we actually have more than 5. We've got 4, we've got 6, so that's actually too many. Could I monkey with that? Probably. So if I take my 5-membered ring, and what are the other requirements? 2 primaries, so 1, 2, and a quaternary. How about like that? Does that work? Then I don't quite get to 1, 2, 3, only 3 secondaries. Not there yet. So you see the idea. You just literally need to be happy drawing isomers and start to figure out your process. And then I'm going to work my way down here. Okay, well, I can have 1, 2, 3, 4. All right, I'm getting closer. 1, 2, 3, 4, 5 secondary, 1 quaternary, and 2 primaries. Shut the front door. I think this works. Okay, now last but not least, I typically give us our symmetry last. Now, you know from our videos, and one of our most common mistakes on this next test, can I tell symmetry with just a skeletal drawing? No. What kind of drawing do we need to see that symmetry? We need bolds and dashes. So if I'm taking something like this bottom structure, we got lucky, but just for good measure, I need to include that. So what if I had decided on this one? How could I show C2 symmetry and a plane of symmetry? I would literally have to draw that, because what if we drew this? That does not, does it? Or does it fit? You've got to evaluate, which one of these fits? Remember, these drawings without bolds and dashes don't tell you which one you have. It's assumed you have both. So you definitely want to end your roadmap by showing those bolds and dashes. And then you can choose something that works. This works. So if you find yourself filling a sheet of paper with those roadmaps, then you're on the right track. Nobody can read the question and just draw the right answer. That's extremely rare. These are meant to be a puzzle. You've got to monkey with them and see what you can draw. Now, they're going to be on every test, and the vocab will be like this. For every test, we're just going to add information to it. We're going to add functional groups, and we're going to have some fun with it. So start here. You have a homework that's called roadmaps, and I'd like you to try your hand at it. Just start drawing structures and see if you know your vocab so well that you can solve these puzzles.